Alright, so we are going to look at this problem, count cells in overlapping horizontal and vertical substrings. It was part of, I think, the last bi-weekly contest. We are given an M cross n matrix grid. It contains characters and we are given a pattern. Then there is two definition of how the pattern should match with the grid, right? So pattern is a string. So we are looking some string in grid, combining different cells. How should we combine it? That's the definition, right? It's a horizontal substring. So basically, if this is the grid, then basically, and this is the pattern, A, B, A, C, A, this is the pattern, right? Then this is a match, this is a vertical substring match, and this is a match, right? So if things are out of bound, then we wrap to the next row. And if things are out of bound in column wise, which it didn't happen here, but if it had happened, then this would be wrapping to the next column. And what about scenario where suppose AA was the pattern, so AABAA was the pattern, then this won't happen, right? So the last cell won't wrap to the first row, and similarly the last column won't wrap to the first row or first column, right? So in that case, this won't happen, right? This won't be matched to anything. If the pattern length exceeds more than 4, then this won't happen. So this is the question. The brute force thing that we can do is basically iterate, right? Iterate here this way and basically keep on doing it for every cell. This start from here, start from here, start from here. So every cell iteration will be uh, O of M or O of P if P is the pattern length, and I'm doing this for n cross m, right? So this NMP is going to be the time complexity if we do it brute force way, and that's going to easily give us TLE, right? So what we can do, the next thing that we can do, or that comes to our mind, is basically three things: either Z algorithm, either rolling hash, or KMP. This will bring down our time complexity to KMP takes how much? N plus M for both building the LIS and searching it, right? Both will together give us N plus M, right? So it'll bring our time complexity to kind of the order O of N cross M, which is good, right? So that's what we need to do. I'll be following the KMP approach. So for that, we'll be building the LIS. But then after that, how are we going to search it? That's going to be a little different because we have wrappings here, right? But that's not going to hamper us a lot because we can always iterate and still do the exact same thing that we need to do. But we have to do it for two things: horizontal substring and vertical substring. And basically at the end of the day, I need to count the number of cells in a matrix that satisfy the fact that the cell must be part of at least one horizontal substring and at least one vertical substring, both at the same time, right? So what we can do is basically build the LIS. I'm sorry, yeah, build the LIS. This is the uh, after building the LIS and searching, right? Basically searching is what? Searching the pattern length will happen at some point here, right? So all of the others should give us 0, 0, 0, 0, or how many zeros? 4 zeros. It matches here, right? So one more row of zeros, and then this matches. So this will be giving us pattern length of 1 2 3 4 5 6 6. This will be 0 0. This will also give us 6 0 0 0. I'm sorry, this is 5, not 6. Pattern length is 5 here, so this will be 5. Okay, so 5 and 5, right? Now, and if I do the same thing, you know what, let me do it here instead. I can't draw. So 0 0 0 0 0 0 0 0. This will be 5 and this will be 5, right? And if I do the same exact thing for horizontal matches as well, actually this will be for vertical matches and this will be for horizontal matches, right? Now we need to combine both. How? We need to combine all the cells that is this first column here. What I can do is I can iterate backwards in the direction of how I iterated for this particular grid. This will be for vertical matching, right? So I iterated it like this and this and this and this. Column wise I iterated. So I'll start iterating backwards now. This. Now I see as soon as I find a value that is equal to the pattern length, I'll start distributing it from here. 1, 1, 1, 1 and 1. And I'll do the same thing here. For this one I iterated in horizontal direction. I'll iterate it backwards. I'll do the exact same thing. Is that? Yeah, that's it. Now if I iterate both the grids using the same index and I add the value, and if any at any point the value of the cell gives me, or the sum of the value of the cells gives me greater than equal to 2, which it does here, I'll count that and that's going to be my answer. So let's write the steps. Basically build LIS, initialize, setup, setup what? Setup the index. I'm sorry, not the index, the container. Let's call this anti-container, vertical container, horizontal, right? Setup containers of grid size initialized with 0 values, and search and build or populate the containers. Basically do pattern matching. Fourth thing is we have two things. Do this for both horizontal, vertical, both for both horizontal and vertical, and this one as well. Now we need to normalize the values of both horizontal and vertical. Normalize containers for both horizontal and vertical. Now iterate and count cells with sum greater than equal to 2, right? So let's discuss the time complexity of each. building the LIS, suppose we are given a string P, string S and string P. So this will be O of P. This will be, oh, this I don't count setup. This will be O of M cross N, right? I'm sorry, this is grid G. This will be O of M cross N again into 2, because I'm doing it for 2 containers. This one will also be 2 into 2, and lastly O of M cross N, right? So technically these will be the time complexity. This will be of order O of P plus O of M cross N, right? P plus M cross N. That's the time complexity we're looking at. Let's code this up. First we get the LIS. I'll create a separate functions for these separate things that we need to do. First thing is we get the LIS. I'm sorry, hold on. String, pattern, and vector. That's it. Pattern is what we need. I'll get a vector lis. Let me get n pattern dot length. This will be of n length. Let's also discuss how to build lis, right? Let me take a good example. Yeah, this is a good example. Let me write the index. The index or the LPS array will be always of the pattern length. These are the index, and initially the values are always 0. For this one, what basically LPS means is longest prefix suffix, right? Uh, so for this A, what's the longest prefix suffix? It's A only. So things are overlapping for both prefix and suffix, and we don't count overlaps. So it's going to be 0. So I'll keep J here and I at the first index, and I'll start filling the LPS, right? So A and B are not matching. So what we usually do is J will check the previous LPS value, which doesn't exist in this case. So we'll move forward. We'll check A and A are matching. So both J and I will increase. But before that, it will update the LPS of I with the Jth plus 1. Whatever the value of J is, plus 1. Why? Because value here indicates the length of the prefix and suffix. J represents here the length of the current prefix before matching, right? 0 is the number of match right now. So we'll add 1 to it, and then that will become that will become 1. We move forward both I and J because they have both matched. Now they are not matching. What we'll do is J will check the previous LPS value and go there. Why are we doing that? Because these many characters have already matched, right? These many characters are already there in the prefix, which is 0 in this case. So it will go to this index of J, right? J will go to the LPS of J minus 1. That's where J will go. And the reason is the LPS, or that is the prefix and suffix, have matched in this case. So this is where J will go, and it will keep on happening until we can't really go backwards, which is in the case here. And we do the case again and again, and until I is exhausted, the entire LPS is filled. In this case, the value will be, this will be 2, this will be 3, this, I'm sorry, this will be 1, this will be 1, this will be 2, 3, 4, 1, 1. I think this will be the LPS for this one, right? So let's build this. We have I 0, sorry, I at the first position, J at the 0th position, and we'll iterate as long as we can. We check if pattern of I is equal to pattern of J. If it is, then we update with what value? J plus 1, and we increment both I and J. Else, what is the case? We keep checking and moving backwards. How far can we go? As long as J minus 1 is greater than uh, pattern dot length, or sorry, it's greater than equal to 0, and pattern of, actually we don't need a while loop here. Why? Because it it can go to the outer while loop and act as if there was a while loop here. So I'll keep moving backwards only if J minus 1 is greater than equal to 0. So what will happen is J will go LPS of J minus 1 else J is at a point where it can't go backwards, that is J minus 1 is 0. So in that case J minus 1 is negative 1. In that case J is at 0, that is fine, and I'll move I forward. That's it, because LPS value is already 0 by default. To be explicit, let's write it here, and we return LPS. Alright, so this is the LPS. Alright, so we have the LPS. What's the next point? We set up the containers with the initial values as 0. So let me get the LPS here. Using the pattern, we get the containers. Let me call it vertical and horizontal. This will be of length m and n. So let's get m comma n. That will be grid dot size and grid of 0 dot size. Lastly, this will be vector of int. Let me call it vertical and horizontal. These are the containers. Now I'll do the pattern matching, right, which will populate the vertical and horizontal with the values where they match. So I need to pass vertical, horizontal, and I need to, for them, both of them, I need to iterate in a particular way, right? Like this one for horizontal and this one for vertical is the iteration that we want. So I want to create a common function so that function can handle both kinds of iteration, right? Or let me do it here and then we will generalize it, right? So we are doing it for horizontal right now. So let's do this. This is basically row wise iteration. This will be J, this will be J and N, this will be J. Lastly, or the next thing is we are going to do the pattern matching for this character grid of ig, right? So if grid of ig is matching with the value uh, yeah, so we need an index k that will act as a index for the pattern, right? So if it is matching, then we'll increment k. After incrementing k, at some point k will be equal to the pattern dot length, and at that point we need to populate the horizontal container in this case, right, with the value of that pattern. So what we can do is, if k is equal to pattern dot length, in that case horizontal of ij is going to be equal to pattern dot length. We need to normalize it later, but at this point this is the case. And now k can go one case backwards to handle all the overlaps as well, right? In this case, for example, there can be overlaps. Actually, in the second example there might be having one. So in the second example we see one overlap here. Let me expand this a little, and here we see the pattern as ABA, right? We see ABA to be here and ABA to be here as well. So at this point a match has happened for this particular substring. So k needs to go backwards. How much it needs to go backwards? Right. So k is out of bound. Right. K is at a point where it is out of bound. So it must be coming here. And how we take k backwards? Like we do it here in building the LPS. LPS of where is it? J is equal to LPS of j minus 1. That's how we move k backwards. So k is equal to LPS of k minus 1. That's pretty much it. Now the case is where it is not equal. If it is not equal, then it's pretty simple. We do the exact same thing, but this time checking if k minus 1 is valid or not. Only then do this. That's it. Actually, the thing is we need to do it here itself as long as we can, because the next thing is I and j is going to be included, incremented to the next thing. So the thing is here we were not doing, let me put it this way. So building the LPS and matching the pattern is very similar thing that we are doing in terms of code. Usually it is very similar, but since we have a two iteration or two loop variables here, what we can do is we can take j as much backwards as we can right here itself. While k minus 1 is greater than equal to 0 and grid of ij is not equal to pattern of k. Keep taking k backwards, and if you can't take k backwards, then we move forward, right? That's what we are doing here. Keep taking k backwards or j backwards. We are not, it is very not, it is not very apparent here, but we are doing the exact same thing. We are taking j backwards as much as we can, and then we are implementing I. But we can't do that here, or at least we can't. If we can, at least with not with this approach we can. So we increment I and j after this while loop, right? So that's it. This must give me the horizontal container populated as I want. So you know what, let me print this, because we are going to copy paste things a lot. Alright, so let me horizontal of ij. I'm sorry, we need to return 0. Alright, let me wait a bit. Let's see, horizontal should be populated correctly, but it is somewhere. Okay, so the thing is, I missed one thing here. See, we are taking k backwards, right? As long as grid of ij is not equal to pattern of k. But the thing is, after this while loop is executed, either k is at a point where it can't go backward, or either this is not true now. That is, they are matching. So what I should do? I should increment k right now, and then the increment of ij will happen on its own, and then I'll be here, right? So that is not happening. What is happening is this has evaluated to false now. Grid of ij is equal to pattern of k, but I'm not incrementing k. I'm missing that k. So and then things are going haywire. So what I can do is increment k plus plus here and expect this to increment, and the things will move. So the things will move forward now. Now let's see, with hopes that horizontal container will be populated correctly, and it is populated correctly. Now I do the exact same thing, but now the iteration will be, let me also copy this. K is already initialized, but now I'm taking this back, reinitializing it to 0. Horizontal, not vertical, column wise iteration. Basically, this will be N, this will be J, this will be J, this will be J, this will be I, M, I. That's it. That's all I need to do. I need to update this horizontal to vertical now, and let's print this as well. Let's hope for the best. Yeah, so this is also correctly giving the right pattern matching. So what I can do is now normalize this. How can we normalize? Basically, we iterate backwards, right? So here we are, this is vertical. We are going to iterate backwards. As soon as I see the value, I'm having a count variable, and I'll keep decrementing the count variable and populating the values one with one value, right? One, 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 and so on and so forth, right? And that's it. That's what we are going to do. But this time the iteration will be reverse, right? So what I can do is I can basically copy this. We will generalize it because we are doing a lot of copy pasting, repeated work, and by at the end of the day, I mean at the end of this whole thing, we will try to generalize it. So I'll have a count variable. This is for row normalization or horizontal container. This will be minus minus. This will be greater than equal to 0. This will be m minus 1. This will be n minus 1. This will be greater than equal to 0. And this will be j minus minus. I will check if uh, as soon as I see the value, that particular cell also should have a value as 1, right? So if horizontal of ij is equal to or it's not equal to 0, then my count will be equal to pattern dot length, and horizontal of ij will be updated to count or 1 if count value is greater than 0, and I'll keep decrementing count, right? So I guess this will give me the normalization of 1 1 1 1 1 in the right direction. I'll do the exact same thing for vertical as well. container, this will be vertical, this will be j now. Is that it? Yeah. This will be n minus 1. This will be j greater than equal to 0, j. This will be I, m minus 1 and I. This will be vertical and this will be vertical. I guess this should be working. Yeah, this should work. What I can do is basically have an answer and do a simple iteration like I was doing, like we always do. And this time we basically get the sum of the two containers, and if horizontal of ij plus vertical of ij is greater than equal to 2, we do answer plus plus and we return answer. Let's see if this works. I'm sorry, this should be j. This should also be j. I guess a lot of copy pasting has some disadvantages. Okay, we don't need to reinitialize it. This works. Let's submit it. It should work. Let's generalize also. Anyway, okay, some problem. Let's see. Oh, I'm missing one thing. The thing is, here we are taking k backwards, right? There can be two conditions when this while loop executes. If this, it can be that grid of ij is equal to pattern of k, or it can be that k is 0. So if k is 0 and this is not true, in that case I shouldn't increment k, right? So I should only increment if this is equal, and here as well if this is equal. That's pretty much it. Let's run this code again. Now generalizing it is basically, it can happen this way, that these two can be generalized in a single function and these two can be generalized in a single function, right? So what I can do is create a void match pattern, which will also populate the container. So we will need the container. It will be in two cases, right? Horizontal or not horizontal. So I'll have a grid first of all. I will need a pattern. I will need the LPS. I will need the container. Uh, Vector container and a boolean value if it's horizontal or vertical. So now either I am iterating this way or this way. There is no other difference in this two code except the iteration. So what I can do is get the start and end based on his horizontal variable. So basically I'll have the same loop here, right? And what I can do is this will be going from 0 to m if it's horizontal, right? So if it is horizontal, then start from 0, go to uh, or start from 0. If it's vertical, uh, yeah, if it's vertical, also start from 0. The ending will be different. Yeah, if it's horizontal, end at less than m or otherwise less than n. Similarly, the opposite will be for this one, n, m. So in this case, j is going to be as it is for the horizontal one, but if it is less than, if it's for the vertical one, then j becomes my row now, right? So what I can do is get the uh, I guess grid value in a character, grid based on is horizontal. If it is horizontal, then grid value will be ij. If it is vertical, grid value will be gi, right? Straightforward. Now the thing is, the entire thing should be same. So I'll copy this code, but ch will be replaced with grid of ij, or grid of ij will be replaced with ch, and that's the case here and here, right? So this should be replaced with this and this. By the way, we need k as well, which I'm missing here, so let me add. Alright, so let me call the two things here, match pattern. This will be grid pattern lps, horizontal is 1 and vertical. Let's see now this works. There is some problem. Grid, so this should be character, not integer. Okay, but okay, m and n are not global variables. Let me make this global. Let's see now. Okay, so it's a container, not horizontal or vertical. Alright, so the thing is, this should be not here. I should be less than m or less than n based on this condition. Similarly, j should be less than n or less than m based on this condition, right? And the other thing is, container should also be switching like this grid of ij. So what I can do is, since I am updating container, I can uh, get a variable container. This variable will be having a reference of the point depending on its horizontal variable, container of ij or container of gi, right? And I'll, instead of updating directly, I'll update it from the reference. Let's see now. Okay, this makes sense. Now also normalize it. So basically we are going to normalize using another normalize container, which will also take a vector of int container. I guess that's it. Container is the only thing that is needed. I'll copy one of the instance, and basically I'll be starting from m-1 or n-1 based on if it's horizontal or vertical. Is horizontal is another variable that I'll be needing. If it's horizontal, then I'll start with m-1, otherwise n-1. Similarly, if it's horizontal, I will start with n-1, otherwise I'll start with m-1, right? And again the same thing, I'll do the similar thing here. The container, and I'll check the container value, and I'll update the container variable. Yeah, I guess this is it. I'll update the normalized container. I'll update it here in match pattern itself, so I'll not be calling from here, right? So after matching pattern, I'll be calling this normalization, right? So inside match pattern itself, I can call the normalized container, where I'm calling the container, and I'm passing the same as horizontal variable from this function itself, right? So at this point, I must be good. Let's see if this works. Okay, something is not right. Container. Oh my bad. I also need to pass the pattern dot length, or you know what? The value of the container as well should be pattern itself, right? So I guess I can do this. Yeah. So let's submit this. Time complexity we have already discussed. So this is the generalized approach, which was a little weird. I guess we can solve it in a different way, even using KMP. But this is what came to my mind. I guess rolling hash could also be an approach that would also require, actually, that might require lesser code. Mm, we can think of that approach, as well as Z algorithm also makes sense here. So yeah,